Hello everyone. So today we will start chapter number 6. Chapter number 6 is about IP addressing. We will discuss everything that you need to know about IP addresses. I have divided this chapter into two parts, and today we will be starting chapter number 6 part 1. In the part number 1 we will be talking about IPv4, and the part number 2 is mainly about IPv6. Okay. So before I jump into chapter number 6 part 1, I just want to actually give you a quick overview of different type of cables, connectors. This particular topic is very important. We have already talked about it in chapter number 3, but this is just an overview how those cables, connectors look like, because this topic is very important from ITS certification point of view. So if you guys are planning to take certification exam, don't forget to watch this particular segment of the video. If you look at the RJ11 connector is where you will see the 6 pins. 6 pins because typically it works with Cat3 cables, where you will see the three twisted pair cable pairs. So three pairs. So all these pairs will go into each particular pin. So that's basically for RJ11 connector. RJ45 connector are typically with 8 pins. Of course, most widely used. That's the one most widely used, and RJ45 connector has already replaced RJ11, by the way. This is for fiber optics. So fiber optic connector to connect, for example, if you are designing your local area network by using fiber optics. So that's the connector which you guys will see. STP, which is shielded twisted pair cable. STP, UTP is unshielded twisted pair cable. These are the way how they look like. In unshielded, if you guys see the unshielded, you don't see any kind of shielding over the cables, okay, like shielding over the cables. But in STP, which is shielded twisted pair, which basically reduce the crosstalk, for example, the data which is traveling between different cables, it will reduce the crosstalk plus the interference. The only problem with STP is, and why it is not that common as compared to UTP, the reason is that the thickness plus this particular the shielding is more vulnerable, more prone to damages. It is more vulnerable, and if for example it got damaged, then what's going to happen, the overall signal will degrade. You will see more interference. This is the Cat3 cable. You guys can see the Cat3 having three twisted pair cables inside it, and that's why we use the RJ11 to connect it. This is how the Cat5 looks like, the one which we typically use. This is the two different type of fiber optic cables, single mode fiber optic and the multi-mode. This is the single mode and this depicts the multi-mode. Single mode is typically used for long distance. For example, if you want to communicate over the longer distance, like for internet connectivity between one state to another state, we use the single mode cables. In single mode, you guys can see here one cable and data travels within that. And typically we use the laser light to transmit the data. In multi-mode, which are basically cheaper as compared to the single mode, here we use LED device. Again, data would be only one source will transmit the data. So this is the data which gets splitted into three different paths. It is just for the one device or one source. Okay, so automatically you guys can see here it will degrade the performance as compared to the single mode, and it can travel up to longer distance. Single mode cables are more costly, and for example, if you want to cover the longer distance, so typically let's say we have deployed a cable for example 100 miles. For the next 100 miles, of course, the signal need to be repeated. We'll place a repeater connector, and this is called splicing. The term is called splicing, where we join the cable. We'll join the other cable for another 100 miles. When we'll feel like or the signal get degraded, it will again, there would be a repeater, regenerator, and then it would be transported to another 100 miles and so. So this is just a small depiction of different type of cables and connector. We have already talked about it. If you will have any question about the cables, please bring it up in the next class. Okay. So let's start with our today's agenda item, which is over IP addressing, and specifically in this video, we will be talking about IPv4 addressing. Okay. So first of all, before we start the addressing of the computers in networking. In networking or in computers, we use mainly two type of addressing. One is called physical addressing, and the second type of addressing is called logical addressing. So physical addressing is, and the major difference, if you want to understand it, in physical addressing is, let's say, for example, anybody, let's say we got a person, and let's say this guy wants to, for example, take a networking class to X from, let's say, me, Dr. Coker. So this particular person wants to take a networking class from Dr. Coker, and this guy, he is in, for example, in New York. And now what happened? This guy got into Georgia, and now he's basically, asking everybody, hey, do you know Dr. Coker? Do you know who is he? Of course, I'm not a famous person, so definitely it's not that easy to find me out. So physical address is basically the address which is a specific ID or specific person's ID. Like, for example, anybody from New York all the way travel to Georgia and looking for Dr. Coker. He'll definitely, it's not going to be that easy to find me. But logical address is basically the address of the network. For example, if the person has the better address, what sort of address? He's coming from New York and he want to reach me out. He want to ask my address or reach out to me. So for example, if he just have an address of, let's say, 1000 University Central Lane, Lawrenceville, Georgia, and then paired with that my name. So automatically it's going to be much easier because he can get to this address and then he can easily find me out. This is basically the network of our network ID. So physical address in technical term, it's the MAC address. MAC address of the computer, typically the MAC address of network interface card. We call it computer MAC address, physical address. And the size of MAC address is 48 bits. Second is the logical address. Now, logical addresses can be of two types mainly. Of course, it is IP address is called logical address. It is IP address. Now, IP address nowadays, they are IPv4 and we have IPv6. There are two variants of the IP addresses. IPv4 size is 32 bits, while IPv6 address is 128 bits. We will discuss that. What's the benefit of using IPv6? If we had IPv4, why we moved to IPv6? We're going to talk about it, and we'll see that all those 32 bits, like, is there any kind of fields, or it's just a solid state single 32 bit. Okay, so let's move on. Let's discuss the definition of IP address, and then we will discuss the overall concept of IP address. So first of all, IP address or IPv4, what IP stands for? IP stands for Internet Protocol. Internet Protocol. If you want to visit any website, let's say this is you, and you want to communicate through your ISP, you want to access, for example, internet, and over internet, let's say you want to access, for example, google.com, or you want to visit, for example, ggc.edu. If you want to visit any computer, any device over internet, you need to know their IP address. So IP address is, what is IP address? IP address is basically the name of a computer or of a device over internet. So if any device, any computer wants to communicate with any other computer over internet, they need to know the MAC address. So for communication over internet, devices or computers need to know each other's IP address. IP address. Just like, for example, the network address and all that stuff. We're going to talk about it. So over internet devices, let's say two computers, computer one wants to communicate with google.com, they need to know the IP address. Your computer need to know IP address of google.com. And if Google wants to respond to you back, they need to know the IP address of you. They need to know your IP address. If they know the IP address, then the communication will occur, otherwise not. And please remember one thing which we have already talked about for local area network communication. For local area network communication, okay, within the network, devices need to know the MAC address. Okay, we have already discussed in the last chapter, we talked about it. Now, let me just give you some basic overview. So this was just a definition of IP address and why IP address is important for communication or networking. Now let's see the concept of IP addresses and structure of IP address. So mainly we're going to see the structure of IP address. So IP address is as we have already discussed, it is 32-bit long. So 32-bit long, and there are mainly 4 fields. We call it 4 octets. Octets mean 8 bits. Like octet is 8. Octet mean 8. So there are 4 octet, and in each octet, each octet, or you can say the field, I'm going to use the octet term here. In each octet, minimum value could be the minimum value could be 0 and maximum value could be 255. We will discuss that why minimum is 0 and why 255. So it starts from 0 and it will go all the way to 255. So we got 4 octet, like the IP address. If you find IP address of any computer, this is basically how the IP address will look like, something like that. For example, the IP address could be 192.168.2.1. like you'll see the 4 octet. This is basically the octet I'm talking about, and each particular, this is called the octet. Okay, and it is made of 8 bits, and it has 4 octets, 4 field. So automatically you can say the total is going to be 32 bits. Now further, the IP address has mainly 2 parts. So if you, for example, divide the IP address, so IP address has mainly 2 parts. IP address depict the network ID. It basically tells the network address, network ID, organization address, you can say, which is basically fixed. You cannot change it. Cannot change, cannot vary to assign anybody. It is fixed, static. Then we got a host ID. Host ID is something which is can be assigned to the client computer, to clients. Okay, variable. So this is basically a variable part of IP address, and the network address or the network ID is something which is fixed. So network ID is fixed, host ID is basically fixed. Okay, now I'm going to explain you the IP address first. Like, let me just take one of the example. I'm going to explain you that, and then I'll explain you the host ID, network ID, the classes of IP address, and different things. So we have discussed IP address is 32-bit long. It contains 4 octet. Minimum value could be 0. Maximum could be 255 for each octet. Like this value can be 0 and it can be up to 255. Okay, just like here we got 192. So the value can be 0. This value can also be 0 to 255, and same goes for other 3 or remaining octet. So let's take example first, and then we will discuss all of that in detail. So let's take example. So for example, I have an IP address, or you are given IP address 192.168. For example 2.5. So this is the IP address. First of all, as we have already discussed so far, each particular field is basically octet. We call it octet. Octet mean each particular field is represented with 8 bits. So 8 bits. And this is, by the way, decimal, the value which we can understand, and that's what we decimal representation. We'll see that how we can represent it into binary, and then it will make more sense to you guys when we convert or we do the subnetting and all. So if you add them together, so you guys can see the total length is going to be 32 bits. So 8 plus 8, 16, 24, 32. So this is, by the way, decimal representation, and we will represent, or we will see that how we can convert decimal to binary. And there are plenty of other types of IP addresses, which is basically the classes called classes of IP address. Like by looking at the IP address, how you can define it, how you can categorize the IP address, like whether it belongs to a large organization, small organization, etc. So in order to see the classes, in order to see the class of IP addresses, which is the categories of IP address, there is a term we call it classes of IP address. So classes of IP address. So class of IP address, let's look at that. So IP addresses have been categorized or classified into 5 different types. We call it class 1 IP or class A IP address. Then we have a class B IP address, class C IP address, class D, and we also have class E IP address as well. Okay, so class A IP address, if I let me just tell you the range, and then I'll explain you how it basically starts. So basically, the first octet, the first octet, the first octet mean the first field. Like this is the called first octet. This is your first octet. First octet defines the class of IP address. Class of IP address. It tells you from which particular class this IP address belong to. So for example, the class A, let's say if the first octet ranges from 1 to 126, like something like that, I'll write it down. We call it that IP address is for is belong to class A IP address, and this class A IP addresses are typically used for large networks. For large networks where you have many computers to connect, many devices to connect, for large networks. Class B IP address, it start from 128, like the first octet start from 128 and it goes all the way 191. So if that's the case, this is typically used for the medium size, or you can say enterprises. Next is class C IP address, which start from 192 and it ranges from 192 to 223. This is for small networks, small local area networks typically. Then we got class D IP address. The first octet ranges from 224 to 239, and the last one is class E, which start from 240 to 255. So these last two classes are reserved. We typically don't use it. This is for multicasting. It is reserved for multicasting, and the class E is reserved for research purposes. Research. So typically we don't use class D and E IP addresses. These are reserved IP addresses. We don't use it for over communication purposes. We don't use them. These are reserved. So the IP addresses typically that we use are basically class A, B, or C. Typically the IP addresses belong to these particular class. Now you might ask a question. I mean, we are missing here 127. Where 127 is gone? Like 1 to 126, and then we jump to 128. Where 127? Where is 127? So 127 and the overall range, like this 127.0.0.0, the overall range is basically reserved for it's called loopback. It's called loopback. It's called the loopback address. So what is loopback address and where do we use it? Loopback address, and let's say one of the addresses is 127.0.0.1. This is your local host address. For example, if you're running any web page or if you're running any kind of server locally, you can call it, you can ping it, or you can call it by using this particular IP address. Why typically we use loopback address? For example, your internet is not working. Let's say this is your computer, internet is down. So for example, your internet is not working, you're trying to connect it. If internet is not working, you can open your command prompt. After command prompt, you can type ping and you can type 127.0.0.1 or 0.0.0. It will basically tell whether your NIC network interface card is good, it is good or bad. For example, if it is good, then for example, I mean, you can check it out whether I have the problem with the cable or not. So you can actually check your network interface card. This whole range is reserved. Previously, it was basically like, I mean, they were not expecting that we will run out of the IP addresses. That's why this overall range has been allocated for this testing purpose. Otherwise, of course, I mean, if they foresee today's future, things would be different. One more thing, which I will, before we jump into the description and the network ID and all that, I just want to show you one more thing, because if you remember, I told you the IP address could have two main parts, network ID and the host ID. I'll explain to you what is network ID and what is host ID in a bit. So for example, let's look at this. In class A IP address, class A, which is the largest one, the first octet, of course, IP address have this main four parts. You guys are clear about it, I believe. Now the first This particular octet is reserved for network, NW network, and H is for host. So the first octet in class A, it is reserved for network. It is the network ID. Network ID mean it tells from which particular network this IP address belongs to. This is the class A. So again, it is fixed, cannot be we cannot vary it, we cannot change it. But these are the three which we can change. We can change and we can assign an IP address to or assign to a client. Similarly, in class B, over first two octets are reserved for network and the last two octets are basically reserved for the host. In class C, which will form mainly the small network, the first three octets are reserved for network and this is for host. This is the network ID. Please remember network ID, and the network ID bit is typically represented as 1, while the host ID or the host bit is typically represented with 0. I'm going to explain you all these, then it will make more sense to you. Let me talk about the network ID first, and then we'll go to the other stuff, like for example the conversion and all these things. Okay, so we have discussed about the classes of IP addresses, and we have discussed the different parts of IP address in class A. Why? Because we can have multiple room for different hosts. We'll calculate the number of possible hosts as well. So first of all, let's talk about the network ID. I don't know why I have the extra page. Let me just delete this one. Let me select this. Let me trash it. Okay, so let's go here. Let's go to this network ID. So for example, I have an IP address. Let's take IP address. For example, it is 15.200.200. For example, 200. Let's say this is the IP address. Now the first question. The question is, can you guys tell me the class of this IP address? IP address. From which particular class this IP address belong to? This is the question. Now what are you going to do? You'll find out. How do you find out? You'll see the first octet. You'll see the first octet, it is 15. If it is 15, you guys know that 15 class A IP address 1 to 126. So 15 falls within this range. So this particular IP address is class A IP address. Firstly, we got it. Once we got it, we know that previously I've shown you guys in class A IP address, the first octet is reserved for network, remaining are for host. So my first, again for class A, we know that the first octet is network, remaining is host. So it means the network ID is, all you have to do is network ID is going to be the first, which is network ID for network. We cannot change it. It's going to be 15. And as I told you guys, host, the host bit, host ID bit represented typically with 0. So host is 0.0.0. Very simple. So straight away, you just have to keep the network number same and remaining bits would turn into 0. This is basically the network ID for this IP address, because this IP address belongs to a specific client, subnetted. We have done the subnetting. We will discuss the subnetting in chapter number 7. In the next chapter, we're going to talk about subnetting. So this is the subnetted. This is the network ID which your organization may have purchased, and this may be the network ID of a client computer. Got it? So what does it mean? Like these zero, this value can be from 0 to 255, 0 to 255, 0 to 255. It means the usable IP address could be, which you can assign to a client, is 15 dot, for example, 0.0.1. This can be assigned to a computer, a client, or 15.1.0.1, for example, it can be assigned. So you can generate as many IP addresses as you want, but there is a cap we're going to talk about in a bit. Let's take another example to understand the network ID. Let's say, for example, you got an IP address, for example, let's say 114.20.20.1. Question: can you tell me the class of this IP address? Which class this IP address belongs to? I'm going to give you a few seconds. Yeah, you got it. This particular IP address, because we saw the first octet, as you know, the class A, it start from 101 to 126. B start from 128 to 191. C is from 192 to 223. Okay, and then D and E. So we will see that 114 falls within class A. This is class A IP address. Again, we know that the first octet is for network, cannot be changed. It tells it is GGC, Google, or whatever. Okay. Then the host part. Network part is going to be same 114. Host part will turn into 0.0.0. This is the network ID. Okay. And we know that your GGC organization or whatever your organization, if any IP address would belong to, any request came from any IP address starting from this, it means this IP address belong to this network ID. Let's take one more example. Okay. Now let me give you another question. Let's say we have 192.168.20.1. Tell me the class of this IP address and the network ID. Network ID. What do you guys think? Class. Yes, that's right. If you guys see, it falls within class C, 192. So it's going to be class C IP address. And what is the network ID? You got it. Network ID is, as you know, we know that this is class C. So network part, and last is the host. So it's going to be, we'll keep the network ID same. And the last is going to be 0. 192.168.20.0. This is the network ID. Reserved or basically allocated for your organization. This is the network ID. I hope you guys got it, how to find the network ID, how to identify the class of an IP address. Now let's discuss the subnet mask. There is a term subnet mask. You guys will see this particular term over and over, especially this term. We will see this particular term in subnetting. So what basically subnet mask is telling us? Why subnet mask is important to understand? Because subnet mask, it tells you the saturation. Tells you saturation in the ID, number one. Plus, it differentiate network ID from host ID. So first of all, let me explain you in easy terms, and then we'll see that the difficult part of it as well. All right, so for example, let's say the question is, this is the IP address 114.10.10.20. For example, this is the IP address. Question is, find subnet mask. So you need to find the subnet mask of this particular IP address. So first of all, we'll find out which class it belongs to. Well, you guys know that which class it belongs to. We know that it belongs to class A IP address. Class A IP address. We know the class A IP address, network, host. Got it? Now, if it is a network IP address, as I told you guys, each particular octet, it's basically of 8 bits. We already know 8 bits, 8 bits, 8 bits, 8, 8, 8, right? Network ID is, or network part is described with the bit 1, while the host bit is represented with bit 0. To calculate the subnet mask, all the values in the network part will make it 111. So it is 8 bits. So 1, 2, 3, 4, 5, 6, 7, 8 dot. Host part 1, 2, 3, 4, 5, 6, 7, 8 dot 1, 2, 3, 4, 5, 6, 7, 8 dot 1, 2, 3, 4, 5, 6, 7, 8. Now, for example, if you guys, this is the decimal, this is the binary. If you calculate the decimal value for that, which I'm going to show you in a bit, the value is going to be 255. You'll calculate that if you convert it. We'll see that. Dot 0, dot 0, dot 0. This is the subnet mask of class A IP address. Any class A IP address, that's going to be subnet mask if subnetting has not been done. If, let me write it down, subnetting is not done, then all class A IP address, all class A IP addresses will have this subnet mask. Same goes for any other class. Same goes for class B, class C, and all. Okay. So for example, let's say you got an IP address let's say 60.20.1.1. So first of all, you need to find out the class of this IP address. What do you guys think? The class? Yes, that's right. This is class B. This is class B IP address. We know that in class B, the first two are network part, network part. The last two are basically host. Network are fixed, fully saturation, 255.255.0.0. You got it. So host part is going to be 0. Network part, by default, we're going to put 255. This is the subnet mask. Let's see, for example, class C. So let's say in class C, we have 192.168.20.1, for example. Now, first of all, we know that this IP address belongs to class C, sorry. This is going to be class C. And again, class C, we have network, 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 and last one is for the host. So 255 for network, network bit 255, 255.0. This is the subnet mask. And again, any IP address belong to class C, class B. If subnetting has not been done, then this is going to be the subnet mask. You might have observed that in our labs, you might have seen that this subnet mask. So subnet mask is very, very important to understand. And it tells you, it differentiates between mainly the network ID and the host ID. Mainly. And again, with the subnetting as well, we're going to talk about it in a bit. So first of all, before I move on to the private IP addressing and other concepts, let me just see how we can calculate the binaries of the IP address. So for example, let's say this is the IP address, and this will also, I'll give you just a glimpse of subnetting here. Let's say you have IP address 192.168.37.10. Question is, calculate binary. Calculate the binary for this particular IP address. I'm sure you have already done it, but I'm gonna actually, I'm sure you guys already know how to do the decimal to binary conversion. But this is just the way how I do it. I'm sure you might have learned different ways. There are plenty of ways to get it done. The way how I do it. So first of all, what I do is I actually start writing down, because it's a binary. So I'm gonna actually place 2, base 2, 0, 1, raised to power 0, 2 power 1, 2 power 2, 2 power 3, 4, 5, 6, 7, and I'm going to stop here. You can calculate how many bits will be 1, 2, 3, 4, 5, 6, 7, 8. Got it? So 2 power 0 is 1, 2, 4, 8, 16, 32, 64, and 128. If, for example, you have 9 bits, so for the 9 bits, we will go to 2 power 8. 10 bits, 2 power 9. 11, 2 power 10. Got it? So, because in our case, it is just for 8 bits. So, for 8 bits. So, we'll go up to 2 power 7. Now, let's see. Let me just remove this so you'll not get confused with that. We'll use this particular numbering as a reference to calculate the binary for anything. Let's say I want to find out the binary for overall this IP address. First of all, I need to find out the binary for 192. So I need to make 192 by using this particular combination. So I need to use this particular, all these combination to make 192. So in order to make 192, this particular bit will be 1. So 1 mean on. So I need 128 plus what? In order to make, I need to make 192. So for example, if I make 64 on, so 192 plus 64, 128 plus 64, it's going to be 2, 1, 9. If you guys see, I'm getting 192. I need to make it 1. So for example, if I add 32, it's going to be 192 plus 32. So 4, 2, 1, 224. I don't want this. So these bits should be 0. 0 mean off. So these bits should be off. If 0 mean off, 1 mean on. Then I can make 192. Are getting a point? So this is the way how I made 192. So 192 binary is going to be 110. So how many zeros? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6 zeros. This is going to be my 192. And let's say now I'm going to make 168. So let's see how we can make 168. Can I turn on this? Yes, I need to turn on this. Can I power on 64? No. If we turn it on, it's going to become 1. We need to make 168. So we cannot add 64. No. We need to make it 0. Can we add 32? Let's add 32 and let's see what happens. 0 1 6 1. Yeah, that's fine, we can do it. So we got 160, but we need to make 168. Can we on 16? Now if we add 160 like this, 160 plus 16, it's going to be 176. No, we don't want this, so it's going to be 0. Can we turn on this? Yes, we need it. So 160 plus 8 is going to be 168. So now this is on, and we got 168, so rest is going to be 0 0. So now the binary for 168 is 101 01 1 2 3 zeros dot. So this is 168. Now let's calculate the next one, and the next one is 37. Let's make 137. So let's see how we can do that. So I want to make 37. Can I turn it on? No, it's greater than 37. No. Yes, we need it. So 32 is here. Can we add 16? No, because if we add 16, it's going to become 48. We don't want 48, right? We need 37. Can we turn on this? No, it's going to become, if you add 32 plus 8, 40. So it's going to be 40. No, we can't have this. Can we end on this one? Yes, we can. So now we have 32 plus 4, 36. Need one more. No, and this. So now what's going to happen? Our IP address is, the binary is 0 0 1 0 0 1 0 1. Okay. Now the last one is 10. We're going to use the same strategy. And all right. So 10, we need to make it. Sorry, let me just clean this as well. So we need 10. So it's very simple. 0 0 0 0 8 0 8 plus 2 10, right? 8 on and 2 on, remaining are 0. So it's going to be 0 0 0 0 1 0 1 0. This is the binary for 10. So 192.168.37.10. So if you guys see, each particular part is of 8 bits. Now I believe it will make more sense if you guys watch it back. If you will have any question, of course you can bring it up in the class, but this is basically how it looks like now. 8 bits of each octet. Everybody got it? You can do the same thing. You can calculate the binary for others. I'll give you practice question in the class. If you want to try, just try to find the binary for 193.168.7.1. just try to find it out, the binary. Okay, take your time, get it done, and then watch back the video. Okay, and bring the question in the class. No, everybody got the idea why. No, let me just give you an example of this. So this is basically the over my IP address, and I know that this IP address belongs to class C IP address, and it's going to be this network ID. As you know, the network ID is going to be 192.168.37.0. This is my network ID. Subnet mask 255.255.255.0. This is my subnet mask. Now let me just slightly give you an example of subnetting, which will give you the better understanding about it. And of course, it's going to be actually open more questions and more ideas for you. Okay, we will discuss that in detail, but this is just a small understanding. Let's say you have purchased this IP address. Let's say you got this IP address 192.168.2.1. Let's say you bought this IP address. For example, this. Now, let's say if you bought this IP address now, and you want to make, and you have, for example, 100 computers to connect. Let's say you have a small local area network. Let's say this is you, and you got different local area networks. Computers. Now, question is, what all these computers, they get the IP address? Are you going to assign all this IP address to everybody? No. We need to do a small sort of subnetting here. So let's say your company name is, for example, XYZ Computers. So you deal in computer XYZ Computer. Now you bought this IP address. Now this particular IP address is basically a class C IP address. You know that the first part is network. This is also network part. This is also network part, and that is only the host part. Okay. For example, this is 0. Let's take it 0 for easy. So now the first 3 parts are basically the network ID. You know that this is the network ID. I cannot change it. This basically tells the class C IP address, and again that tells your company XYZ Computer. And last part is only the host which you can change. So what does it mean? It means this host, you can assign the IP address to this host or this computer 192.168.2.1. Are you getting my point? Now, why 1? Because this range from 0 to 255. Why 255? For example, let's say, if you guys see down here, if I add all these together, so 1 plus 2 plus 4 plus 8 plus 16, 32, 64, 128, the value that you will get is 255. If you add them together, 1 plus 2 plus 4 plus 8 plus 16 plus 32 plus 64 plus 120, you'll get 255. Minimum value is 0. All can be 0. So that's why the range is 0 to 255. Now let's come back here. So this was the network ID. We cannot use that. The first usable IP address is 1. It could be 1. You can assign this computer as a 192.168.2.2. You can assign this to 192.168.2.3. Similarly to other computers as well. Make sense? So this is basically the maximum value could be, you can assign 192.168.1.254. Now your question might be, why not 192.168.2.255? Because that we use for broadcast. I'm going to explain you in a bit. So there are two IP addresses that we reserve. One is network ID. Second is broadcast ID. Broadcast ID. Network ID is the ID of your network. We cannot assign it. Let's say in our example 192.168.2.0. It is reserved. It tells the IP address, like any IP address within the range of this will belong to your network. And broadcast ID is if you want to send a packet to anybody. It is 192.168.2.255. So you can use IP address 1 to 254 within this range. This is, for example, you want to send a packet to all the computers, for example, in your network. Let's say any message, anything you want to send. So that is basically reserved for that particular purposes. Okay. Now, it tells you, like, if you see the subnet mask of this, which is 255.255.255.0. What it tells you this is the network ID, cannot change. This can be changed, which can be from 1 to 255. I mean, technically 0 to 255, but the usable is 1 to 254. Got it? So this is fully saturated. We cannot change it. This last octet can be variable, can be assigned to different computers. I'm going to give you one more example of IP addresses, but let's make it simple. Don't make it too complicated here. We will discuss the subnetting in the next class. Okay, in the next chapter 7. Sorry about that. Okay. Now let's move on to the private IP addresses. Beside the other IP addresses, we have 3 different IP addresses from each class. Let's say in class A, you might have seen this IP address 10.10.20.200. You might have seen this particular IP address in your for example, on the campus. You might have seen that. Typically, this number can be from 10 to, it's not 10 dot then, it's typically the number is 10.0.0.0. Like it could be any value from here. In class B, there is IP address reserved, which is 172.116.x.x, which can be any value, any range. In class C, there is another IP address, which is 192.168. any value. So what exactly this is, what exactly it is telling you? This particular number, like these particular values are basically given for these called private IP addresses. Private IP address mean, like, for example, I want to design my own local area network. So if you want to design your own local area network, you don't have to, for example, purchase any kind of IP addresses. You can let your computers to communicate by using this IP address. Let's say you can make a network 10.0.0.0, and then you can, of course, start giving the IP address to your computers. But this private IP addresses can be used only for local area network, not onto the routers. Plus not onto the routers, plus not onto the internet. So for internet, you cannot use these IP addresses. So these IP addresses can be used locally. So for example, if you want to define, these private IP addressing are used for local area networks. To design local area networks, you don't have to buy them. No need to buy. No need to buy. You don't have to purchase, you don't have to buy them, and you can create a small local area network with that. So you can make a simple local area network with that, which can be so you can further design a simple local area network for that particular purpose. So just to give you an example here, for example, let's talk example about how many computers we can connect with ABC. I think that's should be easy rather than we split up this IP addressing. I'll explain you subnetting in chapter 7. So subnetting we'll discuss in the next coming videos. In chapter 7 we'll discuss subnetting. We'll learn the subnetting by with examples. Now, for example, let's say you have a IP address which is 176.10.0.0. This is your IP address. First of all, the question is you need to find out the class of this IP address, network ID. Then question is find out subnet mask. Then question is you need to find how many computers can be connected. How many computers or clients you can assign. What's the way how we will find out? First of all, the class. What do you guys think which class this IP address belongs to? This IP address belongs to class B. Great, everybody got it. As you know, in class B, we know that first is network, second is network, the last two are host part. We can change it, we can assign to over, let's say 176.10. That is fixed. This is, for example, GGC's IP address, a network ID. Next can be 0.1. It can be assigned to a client. Next can be, for example, 1.0. It can be assigned to a client. That's what the host part mean. No, network ID is going to be 176.10. Network is fixed. .0.0. This is the network ID. Though the broadcast ID of this particular one, if you want to define the broadcast ID, remember I told you broadcast is the maximum value. 176.10 network part is fine. .255.255. This is the network broadcast ID, which we have talked about it here. The broadcast ID, because here is only one part, the host part. But here in the class B IP address, we got two host parts. So this is going to be broadcast ID. This is broadcast ID if you want to send a message to all, send to all the broadcast message. Subnet mask is going to be 255.255.0.0. Got it? How many clients? Very simple formula. It is 2 raised to power. How many different hosts are available? 8 here, 8 here. So 2 power 16, 8 plus 8, 16, minus 2, which is going to be 65,534. So different number of computers can be connected. So what does it mean? If this is your IP address 176.10.0.0, how many computers you can connect? You can connect up to 65,534 computers. The value could be 176.10.1.0, 176.10.0.1, up to 65534. Now, you might ask a question, why, Professor, you subtracted 2? Because this IP address, which is network ID, cannot be used, and broadcast ID, these two IP addresses cannot be used. Okay. So the usable IP addresses would be this. And if you want to find total number of addresses, then you don't have to subtract 2. Let's do one more example. So for example, let's say I have IP addresses, let's say 192.168.2. For example, 0. Let's take that. Now, first of all, network ID. So network ID is going to be, what's the network ID? 192.168.2.0. This is the network ID, by the way. Okay, this is the network ID. Now, subnet mask. If you want to find subnet mask, so as you know, the subnet mask is going to be 255.255.255.0. Why? Because class C IP address, this is class C IP address. .network .host, right? So host is 0, of course. Network part is full, saturated 111. Then broadcast ID. Sorry, this was network ID. So now next is broadcast ID. So the broadcast ID is going to be 192.168.2.255. Okay, this is broadcast ID. Now, number of computers, how many computers can be connected? look at this IP network ID. You guys know that 8 bits are only, these are fixed. These are fixed. Only host can be changed and 8 bits are available. So 2 power 8 minus 2. Minus 2 because we have network ID and these two, right? So 2 power 8 is going to be 256 minus 2, 254. So 254 computers can be connected if you have this IP address. Let's take one more example with class A. Let's say in class A IP address, we have 10.0.0.1. For example, this is your IP address. Now, what would be the network ID? This is class A, as you know, first octet. Network ID is going to be 10.0.0.0. Broadcast ID is going to be, what would be the broadcast ID? 10.255.255.255, right? So we know that network part first, host, right? So this is going to be fixed and these will be, of course, 255. If you want to find subnet mask, in subnet mask, it's going to be 255. The whole network is going to be 255.0.0.0. Like these are variable. You can change it. And how many? We got 8 here, 8 here, 8 here. So if you want to find number of usable IPs which you can assign to client, 2 power 24, 8 plus 8 plus 8, right? Minus 2. Again, these broadcast ID and our network ID has been subtracted. It's approximately 1.6 million. You guys will see approximately 1.6 million if you calculate it. Okay. So theoretically speaking, by the way, if you know that we don't, I mean, even though if you see class A IP addresses start from 0 to 127, but actually we use 1 to 126. We don't use anything from 0 because the first octet, if we use 0, that's not a usable. It's basically on your own, telling you the PC on your own site. So this is a quick introduction of IP addresses. I hope everybody understood it. If there would be any questions, please do bring it up in the next class. Today we have talked about the IPv4. We have discussed the structure of IPv4, 32 bits, how we can convert it, classes of IP addresses, network ID, and other concept. In the next class, we will discuss IPv6. We will discuss it in detail. Plus, we will discuss some other network terminologies like the NAT, PAT, etc. We will discuss that in the next class. Thank you.